today we're going to talk about the circle vocabulary, and we're going to talk about how to find arc length and sector area. And you'll see this 10 JLab questions, and you're like, I don't know what that is. Hold on, you will. And then you can see we're going to talk about tangents, chords, arcs, and angles. And then here is your SOL review day, and that is the day we're going to go over that algebra review homework you had after the test. And then you keep seeing these 10 JLab questions. Angle relationships in circles, segment properties. You will have a quiz for this unit, but no test until after the SOL. So our time is precious, and we're going to make sure that we spend it learning content, and we'll test after you take your SOL. Did everybody check their Gmail in TA today and see the email that has your SOL schedule? So if you didn't, make sure that you log on to your FCPS school's Gmail account. And you're going to see that there's 4 days where the entire school is on a weird schedule. On this first day, there's no third period. First period is 3 hours long, and that will be for the biology SOL. That's what you guys will be taking that. To balance out that, the next week, there's a time when there's no first period and a 3-hour third period for, I believe, your world history SOL. I could be wrong on that one. Here on the 6th of May and the 12th of May, the SOLs are on an even day. And both days we don't have stinger. But on this day, second period is a 3-hour one, and on this day, 8th period is a 3-hour one. So that schedule and your specific SOL schedule is in your FCPS Gmail account, so you can look for that. Okay, we're gonna have 3 SOL review sessions. Your first SOL review session will be next week during that cultural religious observant day. And then we're going to do a second review session. And then your third SOL review is going to be right before the test, and then your test is on the 3rd. Like I've said before, I'm not worried about anybody. I don't worry about whether or not you're going to pass. Honors geometry student, that should be a given. But we just want to make sure that we send you in there feeling confident and ready for that test. For that reason, if you flip over your warm-up, you have this conversation, which is an SOL review assignment that has you doing JLabs. Has anybody heard of JLabs in the past? Okay, so I know science does them a lot at the middle school. And we used to do them for algebra in the middle school. But here's how it works. We're going to give you, I'm going to make sure that this link is posted on Schoology. And when you click on that, you're going to come down and you're going to choose an algebra test. You're going to choose how many questions that you want to answer. And you're going to type in your first and last name. And can I have you star and circle this? Because if you don't add your name here, I don't know who to give the credit to. So go ahead and give yourself a star and a circle, because I want your first and your last name. One year I had a ridiculous number of Liams, and I never knew which Liam it was. So make sure if you want the credit, first and last name. You're going to click I'm ready, let's start. And then you're going to go ahead and take some SOL review questions. Now, if you're frustrated when they're giving you questions that either you haven't seen before yet, or if you want to target areas that you need the most help with, you can go under select additional options and you can choose one of the 3 reporting categories on where you want to focus for extra help. All right, here's the next thing you need to star and circle. Are you ready? You must score at least a 70% in order for the questions to count. So what I'm going to do is you're going to email me your results. And I have my email set up that all of my JLab reports are going to go into a separate folder. And on the day of the SOL, I'm going to go in and tally up how many emails you've sent me and how many questions that you've done. Any test that is less than a 70%, don't bother sending me because I'm not going to count it. You're going to email your results to me. Make sure that you have my email right. It's T as in Tracy, J as in Jean, GLAZIER @fcps.edu. Make sure you know this is a J. Kids get that mixed up. When it's all smushed together with the underline, it looks like an I. So my name is Tracy Jean, JEANNE. You email me those results. You can also send a copy to yourself. So if there's ever any discrepancy, you and I both have record of them. Please don't double email me because the way that my email sorts it, it'll put those emails right together again. And I'll know that you're trying to get double credit for half the work. And then I have a bad feeling about you, and that's not fair. So just don't do that. I'm going to tell you right now, the way that the technology does it, you can't get away with that. All right, here's what you're going to do. I'm expecting you to do 100 questions. If you do 100 questions at 70% each a minimum, you get 10 out of 10 on a quiz grade. So I'm not grading them. You just have to get 70% in order for them to count. Does that make sense to you? If you do 100 questions, you get some right, you get some wrong. That's okay. As long as you get 70% of them correct, you can still get a 10 out of 10 on the quiz. If you send me 90 questions, that's a 9 out of 10. If you send me 80 questions, that's an 8 out of 10. Are you with me on this? Okay, here's the cool part. Notice it's on the back of your sheet. You're like, oh man, we don't get extra credit for this unit. Yeah, you do. Because if you send me 110 questions, that's an 11 out of 10. Ah. If you send me 120 questions, that's a 12 out of 10. If you send me 130 questions, that's a... What if you send me 200 questions? Yeah, because we have a maximum of 15. But you can get up to 5 free quiz points for this fourth quarter. So that's a nice big chunk of extra credit available to you. Everyone is expected to do 100. If you get your 100, you get your 10 out of 10. You're like, I'm not going to do any more. That's fine. But for those of you who need a boost to your grade, that's a good option for you. Would you please turn to your group mates and share your experience with JLabs, whether you've done them or not, and what it is that you want to make sure that you get right. You mark it, set, go. Yeah. I will put the link. I will put the link in let me see if I can find JLabs. I want to find JLabs. So if you JLabs, that's what review. If you go to, that's all you need to do to search, but I'll put the link into Schoology. But you go to Algebra 1, you choose how many questions you want to do. Something that's important to note, if you choose 40 questions and your computer runs out of charge, or your mom calls you for dinner, or you got to go, there's no way of saving. So you will lose. If something happens, you will lose all your hard work, and there's nothing anybody can do about it. So my recommendation is to not do 40. If you have a good chunk of time, you can do 20 at a time. My recommendation is 10. I don't recommend doing 5s because you don't get enough of a variety in types of questions to practice. Remember, you're doing this to prepare for the SOL. The more practice you do, the more reviewing that you get. Plus, if you do 5, as soon as you get 2 wrong, you're below a 70%. So if you're taking a 10 question, you get 3 wrong, right? If you're taking a 5, there's no way to get a 70% because you can't get 2.5. Are you with me on that? So as soon as you get a couple questions wrong, you're out of luck. So I would recommend doing 10s, do 20s if you have a good chunk of time. Add your name first and last. And then when you say, I'm ready, let's start, it'll tell you, oh, did I press Algebra 1 by accident? Should have pressed Geometry. Anyway, when you pick an answer, that's my final answer, okay, it'll tell you if you got it right or wrong. Typically, you can go ahead and click on this and read an explanation that'll go through and tell you why it is that you got something wrong. So that's really nice. Remember, you're not in this just to get it done. You're in this to review. You're in this to stir the pot, get all that old stuff back up in your brain one more time. When you go on to the next question, once you miss, let's say you're taking a 10 question, once you miss your third one, just bail and start over because you want to make sure that you're getting a 70% on the ones that you submit to me. Make sense? If you're curious where you are, you can hit view results and it'll go through and tell you the reporting category. It'll tell you your right or wrong answer. It'll let you know your percentage so you can go ahead through. If it's not going well for you, go ahead and start over because you want to make sure you end up with at least a 70%. Make sense? Questions on the JLabs? So the way that we have this worked out is we have you doing 10 questions over the next 2 weeks each night. If you get in a groove and you want to work ahead, awesome. I don't recommend that you get too far behind because we did have to throw in a couple 20s to make sure that you get all of them done. So working ahead, good idea. Blowing it off and saving it all for one night, bad idea. Sound okay? All right, awesome. Here is your warm-up. Today we are starting to talk about circles. So our first conversation here, what is a circle? The formal definition of a circle is the set of all points in a plane that are given distance from a given point in the plane. The given point is the center of the circle and the given distance is the radius. So that's kind of confusing. It's easier if we think about the circle as this, a curved line that forms a closed path on a flat surface. So a curved line that forms a closed path on a flat surface. So it's a two-dimensional conversation. All the points on the circle are the same distance from the center of the circle. The center is not a part of the circle and the interior is not a part of the circle. Would you and your group mates go ahead and do your best to sketch what you think is a perfect circle? Would you please make sure that there's materials in your baskets like straight edges and colored pencils? Because once you sketch your circle, I want you to go ahead and
Go back. Do it again. Slap twist.
once you sketch it, I want you to go ahead and label the parts of the circle that you know. Look at those vocabulary. We're going to talk about them in a minute, but then at least you can label the parts that you know.
You know what? I gave up.
Gabby's our circle expert. All right, so I'm passing a bunch of random colored paper out. Do me a favor, let's try to be paper conscious. Because your next step is I want you to cut a perfect circle. That's why you have your colored pencils. We're going to keep using the same paper and pass it around to each of the different sections so we don't realize. So instead of cutting it out in the middle, maybe cut it out on the edge so we can use the same paper for another group. Does that make sense what I'm asking? So once you draw as close of a perfect circle as you can, go ahead and cut a perfect circle. And I want it to be about the size of a coffee mug. So that, and you're welcome to do whatever tricks that you can, whether you want to fold the paper, anything that you want to do. But we're going to try to do it towards the edge so we don't use up all the paper. Does that make sense?
That's an edge.
So here is my sort of circle. I tend to make them a little flat. I don't know, I heard somebody talking about that they had an egg. Ariane's got a great football going on. Hey, that is the circle. The circle is all those paths that are equidistant from one center point. Just what's in purple is part of the circle. This center is not part of the circle, but that center is necessary because the distance from the center to all of these outside points has to be the same. And we can go ahead and call that distance, the distance from the center to that path is our radius. If I have a segment that goes from one endpoint and has one endpoint on the circle and another endpoint on the circle and goes through the center, that is called the diameter. The diameter is a special kind of chord. So a chord is a segment that has its endpoints on a circle. So notice any segment that has endpoints on the circle is a chord. A special kind of chord is the diameter that goes through the center. The radius is that distance from the center to the outside of the circle. So we can begin to see the relationship between a radius and a diameter. What is it? Relationship between the radius and diameter, what is it? Yeah, radius is half the diameter is double the radius. So it's a 2-to-1 story. A secant line is going to be any line that intersects the circle in two places. So a secant line extends in both directions forever and ever and intersects the circle in exactly 2 places. Can you see the relationship between a chord and a secant? A chord is a piece of that secant. So the chord is from endpoint to endpoint. The secant is the line that goes all the way through it. A tangent is going to be a line that intersects the circle in exactly one place. Exactly one place is what a tangent line is. Anything that is inside of the circle is what we call the interior. Anything that is outside of the circle is what we call the exterior. So I'll give you a minute to update your notes and update your perfect little circle. And when I come around, I want to make sure that you have your name on the one side and these, oh, I forgot one. What word did I forget? Yeah, what is the circumference? Yeah, perfect. That's our distance around. So our circumference is going to be that distance around the circle. So update your notes, update your perfect circles. Your perfect circles have your name and period 6 on one side and these vocabulary words on the other side. Keep the scissors, put the scraps back in the lid for if another class could use them. And any cuttings can go in the recycle bin that's in the center of the room. I'm going to move on in exactly 2 minutes. Yeah, you're not going to be able to. So yes, or you can write this or something.
Okay, and I can't put it
Yeah. So Cece's right. Don't worry about the exterior on your cutout. And don't worry about your tangent and secant on your cutout. Does that make sense? All right, so on the other side, everybody always knows pi as this irrational number and you like to talk about it. Typically, we would have done a lot of these activities on Pi Day, but we didn't do that this year. So I think it's important that you see that pi is a constant. Pi is this value that exists. And we understand the closest ratio for pi that we frequently use is 22/7, but that's a rational number and pi is an irrational number. So because it's an irrational number, it cannot be written as a ratio. So this is a close estimation, but not really. 3.14 is the decimal that we frequently use for pi. And again, it's a close estimation, but it's not exact because that's a decimal that ends. It terminates. And pi is an irrational number, a number that you can divide out forever with no patterns that you can find. We discovered pi when we found the relationship between the diameter and the circumference of a circle. So what you're going to be doing is calculating pi. So your group mates are going to come back and you're each going to pick a circle, some form of circle. And what you are going to do is you're going to measure the distance around, which is the circumference, measure to the nearest centimeter. And you can use millimeters, so if you want to go into like 2 point or whatever, you can go ahead and do that. Using the centimeter ruler is easier. And then you're going to measure the widest part across, and that is going to be the diameter. So the easiest way to do this is to put the circle down and slide your measuring tape up and back and finding where it's at its widest point, and that's going to be the diameter. When you take those two values, your circumference, and you divide it by the diameter, you're hoping to get 3.14-ish. And let's see how good you are at measuring. So I'm going to come around and I'm going to give, and I want you working in groups of 2. So right now, each table group, if you are sitting in quadrant 1 or 2, go back and pick 4, each pick 2, bring back 4 circles for your group to play with. Quadrant 3, come get a measuring tape from me. What we were hoping that you would find is the circumference divided by the diameter just about gave you 3.14. Now, you might have had it go on and on and on, and I saw a couple groups going back and adjusting their measurements, being like, well, wait a minute, I don't think that we were as precise as we needed to be. Because if you didn't get 3.14, then you messed up somewhere in the diameter and the circumference measurement. It's kind of cool. Imagine in ancient times, our Greek and our Roman mathematicians measuring all of these circles and saying, wait, are you kidding? Every time we measure the distance around and we divide it by the distance across at the widest point of the circle, we get the same value. So it's a constant. So we can talk about how pi is that constant rate that exists, that comparison between the circumference and the diameter. And we use that to calculate the circumference. If you knew what the diameter or the radius was, then you can find what the circumference is by using this 2 pi r. Sometimes we say circumference is equal to pi times the diameter, or 2 pi r. That is something you need to have memorized in your brain. If you like the twinkle twinkle little star, circumference equals 2 pi r, maybe that'll help you remember that and keep that straight. Circumference being that distance around. Okay, next up we're going to start talking about the area of the circle. When you're finding the area of a shape, you're finding how many square units fit into that shape, into the space covered by that shape. And that's really tricky with circles because there's no sides. The circle doesn't have any edges or sides, so fitting a square into that round shape is impossible. So the formula for the area of a circle is pi times the radius, or pi r squared. If you want your cute little poem for this, Fuzzy Wuzzy was a bear, area equals pi r squared. So that can help you remember that. Tons of fun. And I'm going to show you how that works. Are you ready? Everybody gets a shape similar to this. You all have it. And I walked around and passed them out. But some of you have a circle divided into 4 sectors. Some have a circle divided into 2 sectors. The one I'm going to work with here has a circle divided into 8. I think there's a 10. And I think there's a 12. So either you have a 2, a 4, a 6, an 8, a 10, or 12, I think. All right, so here's what I want you to do. Regardless of what circle you have, I want you to take a colored pencil. Now, I have colored pencils up here, so if your basket doesn't have colored pencils, you can come grab another one. But listen first. I want you to take a colored pencil, and I want you to listen. Listen, listen. I want you to color half of the sectors of your circle. I want you to color half of the sectors of your circle. And then I want you to take out your scissors and I want you to cut out not only the circle, but also all of the sectors. These little triangle-ish wedgy shapes are called sectors of a circle. And I want you to color half of them. And then I want you to, with your scissors, cut out each of the different sections. All right, so once you finish cutting, what I want you to do is I want you to arrange your sections so that they look like this. I want you to arrange each of your sections so that you have a colored shape alternating with a non-colored shape. And what's interesting is your group mates and you do not have the same number of sections. And where you choose to fit this on your paper is up to you. and I put pieces of scotch tape, or I put scotch tape there. So once you get your sections arranged, go ahead and take a piece of scotch tape and tape them down. Okay. So that you save them. Because this is what I want you to see. There's two goals that I want you to see. The number one thing that I want you to see is that this length right here, is 1/2 of your circumference. Does that make sense why that's 1/2? Where's the other half of the circumference of the circle? Yeah, down here. So if you think about this circle, here and here and here and here is halfway around the circle. Now what's interesting is I want you to peek at your group mates' papers, because if you have a circle that was cut into 4, the bumpies are a lot bigger. If you have a circle that was cut into 10, the bumpies are smaller. If you have a circle that was cut into 6, the bumpies are somewhere in the middle. So depending on how many wedges, whose is the most accurate at your table? Whose is the least accurate when it comes to representing this distance being 1/2 of the circle? Which one is more accurate? Charlotte, what'd you guys figure out? Yeah. Take a look at Maria's. Can I borrow? Look how beautiful. So she's got, and then can I borrow? Is it tape down? Check it out. Here's the idea. Are you with me? Here's the idea of, in calculus, we talk about limits. And we talk about approaching something, but knowing we're never actually going to get there. The more sectors I use, the closer I am to what shape. What shape am I approaching? The more sectors I take and cut out, it already is a circle. What shape does this look like to you? It's approaching a parallelogram. It's approaching a parallelogram. Stay with me, please. Stay with me. Because it's approaching a parallelogram, I know the formula for an area of a parallelogram is going to be my base times my height. Stay with me. If my base is 1/2 of the circumference, 1/2 of the circumference, my height is going to be, what's this in terms of a circle? It's going to be the radius. Okay, here's some craziness. Everybody hang on, are you ready? Your area is equal to 1/2. My circumference is 2 pi r times my radius. Do you see how this 1/2 and this 2 cancel out? pi r squared. Go to lunch.
I like that.
It's interesting to see the more sectors that you have, the closer you are to that parallelogram. So I'm going to borrow a couple people's papers. Just I want you to compare what Charlotte has here. Not very parallelogrammy. Closer to being a parallelogram. And with the more sections, look at this one. And you can see that. So if I divided the circle infinitely into many, 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 many sections, that radius is my height. And that base is half of the distance around the circle. And that distance is the circumference. So if the circumference is equal to 2 pi r, half of that, and this is what we got right before lunch, half of that is just pi r. And that's where pi r times r, or pi r squared, comes from for our area formula. Kind of cool. All right. On your table groups, I put today's notes. Would you please, with your group on your mark, set, go, identify these circle parts, and we'll talk about the ones that are new to you. You have 30 seconds. Go. All right, let's talk about some words that might be new to you. The circle we have as this collection of points that are equidistant from any center point, and C is my center. My radius is going to be line segment BC. My diameter is line segment EG. When we start talking about a chord, there's a couple of them here. You could talk about EG as the chord. You could also talk about chord HF. When it comes to talking about the secant line, line HF is going to be the difference between having endpoints on the circle, which is the chord, and being a secant line that continues and intersects the circle in two places. Our tangent line is going to be line AD. You could also call it line AB. You could call it line BD, as long as you have this line here. And this point of tangency is where it hits in just that one place, which is going to be point B. So when we start talking about semicircles, arcs, minor arcs, and major arcs, adjacent arcs, that's our next big idea that we're going to talk about, those pieces of those circles. So when we're talking about a semicircle, that semicircle represents half of the circle. So we're going to represent it as an arc. So this semicircle starts at E and ends at G. And we have to let everybody know which part of the circle we care about. So we're going to throw in this third letter, letter H. So the arc notation is a curve up above, where it starts, what it goes through, and where it ends. The way I differentiate between this semicircle and this semicircle is what letter goes in that middle. If I wanted to say the other half of that circle, give me an example of what I could have called it. Arc EBG. What else? Arc EFG. If you said arc EG, I wouldn't know which one you were talking about. All right, so when we're talking about an arc on the circle, an arc is going to be a section of my circumference. The distance between 2 points on the circle. We have two kinds of arcs, minor arcs and major arcs. Minor arcs are going to be smaller than 180 degrees. So if I'm talking about minor arc BG, I know that that's going to go from B all the way around to G, and I know that its measure is going to be less than half of the circle. 360 degrees all the way around, 180 is half of the circle. I don't have to include the F there, because if I said arc BG, there's only one way to get from B to G that's less than 180 degrees. Are you with me on that? If I wanted to know my major arc, I'd have to let everybody know I'm going the other way around the circle. So again, starts with B, ends with G, and whether you put E or H in the middle, nobody cares. Because we're talking about that traveling around the circle. Adjacent arcs. The word adjacent is always going to mean the same thing. Arcs that are next to each other. And a central angle is going to be an angle where your vertex is on the center of the circle. So when I talk about a central angle, it's got to have the center of my circle as the vertex. So angle ECB is a central angle. Now, as we discovered in our area conversations, a sector is going to be a portion. Think of it as like a pie wedge. That sector of the circle, if you want to think of it as a piece of pie, is going to be that area of the circle that's defined by this central angle. A segment in a circle is just going to be any piece of a line. Same thing as a line segment usually means. And when we talk about our points of a circle, everything is either inside, outside, or on. Those are exclusive terms. C is in the center of the circle. That's in the interior. A is in the exterior. So we'll tell you interior, point C, and point J. Exterior, points A and D. Everything else is on the circle. So E, B, F, G, and H. Sound okay? Share with your group any of those words that are new to you and you mark set go. We need to make sure in our conversations that we're careful about making sure that we know the difference between the measure of the arc, which is going to be in terms of degrees, and the arc length, which is going to be measured in whatever units our circumference is. So when I have a minor arc, that's when my measure is less than 180 degrees, and it's equal to the measure of its corresponding central angle. So because I have a 50-degree arc here, I know that the measure of arc AC is also going to be 50 degrees. Keep in mind that has nothing to do with the size of the radius. So whether my circle is itty-bitty or huge, that degree measure still applies to that arc. When I have a major arc, that's the major arc that goes from A to C through B, and that's going to be equal to 360 less the measure of the related minor arc. So basically, if I have 360 minus 50, these 310 degrees that complete the circle is what my major arc. our semicircles are always going to have an arc measure of 180 degrees. And they don't count as a major or a minor arc because it's a semicircle. It's equal to 180 degrees. Minor arcs are smaller, major arcs bigger, semicircles equal to 180. All right, our arc addition postulate is exactly the same. So remember when we talked about our segment addition? Remember we talked about our angle addition? Our arc addition is the same. So if I'm looking at arc ABC, that's going to be the measure of arc AB plus the measure of arc BC, and I can add them together. When we shift gears and start talking about arc length, that's going to be the ratio of the length of an arc to the circumference. And what we're doing is we're taking a piece of the circumference. So what fraction, what part of the whole do you have? Now you can set this up as a proportion. So if you're a person who likes to think proportionally, you can think about the arc length to the circumference is equal to the degrees to the degrees, the measure of the central angle, and you can say the piece of the arc compared to the whole is equal to the piece of the circle compared to the whole. So we talk about the part and the whole. Some of you guys like equations better. So if you're an equation person, my arc length is going to be equal to whatever this fraction of the circle is, whatever the fraction of the circle is, times the whole. So if you're a proportion thinker, you like the first in red. If you're an equation thinker, you like the green. So let's flip over and try a couple. Given circle B, find the measure of each central angle. So when I talk about JBG, what does this symbol mean? That's a 90-degree angle. This hole punch went through letter H, so put H there. With your group, go ahead and figure out each of those angle measures for those central angles. You mark, set, go. All right, so let's check it out. If I have HBI, that's got to complete this linear pair. So what's that get me up to? 29? Agree? All right, let's talk about GBI. That's going to be my 90 degrees plus my 29. You okay with that? So, did I do my math right in my head? Check me. All right, GBH is also going to be 90 degrees. Let's talk about IBJ. That's already given to me as 151, right? And then HBJ is going to be 180 because that's straight line. Are we all okay with that? Yeah. All right. Now here comes the fun part, finding the measures of each arc in circle B. Just do this first column, please. Do we agree? We're going to scoot down. We'll come back to these in a little bit. Find the circumference of a circle with radius equal to 9 degrees. My circumference is equal, whether you think of it as 2 pi r or your circumference is equal to pi times your diameter, your circumference is going to be equal to 9 pi. Now, here's what's interesting. We're going to have those stories again where do I want an exact value? Oh, 18. Why didn't you say something? Where we talk about, are we doing exact value or are we doing our estimate? So when we talk about pi, 18, here's our pi button right here on the calculator. Can you see it? It's this second function, right? So when I do second pi, it's going to give me an estimated value. And again, we're going to round to the nearest hundredth. So 56.55 inches. Remember your units. Circumference is the distance around the circle. So it's going to be a linear measure, which is just plain units, nothing squared. Real quick, I'm going to come down and give you an example of how to find the measure and length of each minor arc. We're going to do this one, arc EF. It has a measure of 140 degrees, but the length of arc EF is going to be equal to its piece of the circle times the distance around, which is 2 pi r. So this is the fraction, which is the piece of that whole circle. So this is my length of my arc, and that's going to be equal to this fraction of the whole. If you're a person that likes proportions, we can go back and say 140 out of the 360 degrees is equal to the length of EF compared to my 2 pi r. So whether you solve by cross products, notice it's this fraction times that circumference. So when I go to do that math, I have 140 divided by 360. That's my fraction times 12. 6 times 2 is 12. So the length of my arc is equal to 4.67 pi. So when I multiply it by pi and I round, I get 14.66. It's a linear length, so it's going to be millimeters. So you're looking for what piece, what part of the whole, what fraction do you have? I have 140 out of 360 degrees. All right, I know we're racing, so go ahead and pick up the second half of today's notes. And let's start talking about area. If you go on to MathSpace and you look at areas of circles, you can find this widget that does exactly what we did today with our cutting up into the circles. So let me see if I can pull it up real quick. In MathSpace, under areas of circles and sectors, watch what ends up happening. I can unravel this circle. How cool is that? So that's that circle unraveled. We can put it together and take it apart. How cool is that? Then I take half of the circle, spin it around, and then I can slide them together, which is just what you did. And that's how you end up with your area is equal to your base times your height. Half of the circumference is pi r. Your height is r for radius. So the interesting thing about these two sections is we cover the same idea about finding the area of the sector. So our area of the circle is pi r squared. The sector is the portion of the interior of the circle defined by two radii in their arc. So here's our circle sector of AB. And your area of the sector is the same part to whole, and either you want to talk about it in terms of a proportion, or you want to talk about it in terms of an equation, where your sector area is equal to, and remember this measure of arc AB is in degrees. How many degrees does your sector have compared to the whole? When we have this area of a segment, that's my area defined by a chord in the intercepted arc. And that's where we have the area of the sector minus the area of the triangle. So the area of this segment is going to be what's left over. And you'll have to do some of those machinations also with your homework. Your homework is the back of both of these sides of paper. So we started a little bit of it, but I want you to work on it. MathSpace is a really good reference for you to check out.